Hey guys, it's Mr. Walker here, and today we are jumping into the next lesson of our math content curriculum that we've been working on forever now. And in this lesson, we're actually going to be talking about dividing decimals. Okay, so we've been working with um, multiplying, and then we did some multiplication with decimals, and then we worked on some regular division with whole numbers, and now we're working on dividing with decimals. So we're kind of stepping up our game each time. And as you may notice today, you don't see my lovely face, and I apologize for that, but I actually need like the full screen to be able to write on today. You don't even need my little head in the way because we got a lot of work that we're going to work through together. So we're just going to jump right in and look at some examples together and see how we can move from regular division into dividing by decimals and into dividing decimals and seeing what kind of things are the same and what kind of things are different as far as the strategies behind doing both. Okay, so really all you need today is something to write on, something to write with, and then we should be able to get started. All right, so you can see here on the screen I have two division problems written up here, right? And we don't have any decimals involved in these yet, but right now I have 904 divided by 32, and I have 456 divided by 16. So I'm going to work through both of these division problems using the standard algorithm just to see what the answers are, and then we're going to talk about that for a minute. So if you want to solve these on your own first, and then you can see what I get, or if you just want to press continue and you can see what the results are, either way is cool with me. All right, so I have both division problems completed here using the standard algorithm. And as you can see, even though I started with totally different numbers here, what do you notice about the answer, the quotients to both of these problems? Yeah, our quotients are both 28, and we have a remainder of 8 with both of these. So even though we have totally different numbers, my answers are the same. So just because my answers are the same here, does that mean that the two division expressions would be equivalent? And what I mean by that is if I wrote something like, or could I write something like 904 divided by 32 is equal to 456 divided by 16. Would that be equal? Would that be correct? Well, we could say that yes, these are kind of equal. Just like I could say like 2 plus 2 equals 4 and 3 plus 1 equals 4. So technically 2 plus 2 is equal to 3 plus 1, right? They're going to get to the same answer. But because of the remainder and everything that we have left in these problems, it gets kind of tricky. It gets kind of hard to see, like, are they actually the same? Or are they giving us the same amount? Are they equivalent? But there is a way that we can find that out. And if we look back at the first problem here, this 904 divided by 32, what we did was we divided through all the different place values, right? The hundreds, the tens, the ones. And then when we got to the ones, we stopped. We said, okay, there's our remainder. Remainder's 8. That's it. We're good to go, right? But can we decompose those 8 ones that are left over? Can we go any smaller than that? Think about what we've learned earlier in this year. Think about what we know about like decimals and things like that. Can we go any smaller than 8 ones? Sure we can. We can go to tenths, right? That's our next place value, smaller than ones. And we know that. We've done that all year long. We've learned about place value in that respect. So let's do that. Let's think of this 8 ones instead as 80 tenths. Now, how do we do that? How do we actually get to that point? Well, think about this for a second, this 904. If I put a decimal point here and a 0, does that change the value of this number at all? I have 904 and 0 tenths, or I have 904 when I had nothing there. Does that change the value of it at all? No, it doesn't change the value of it, okay? I just was able to move to the next place value now. So now what I'm basically doing is I'm bringing down the 0, but not so much bringing it down as I'm regrouping now these 8 ones as 80 tenths, okay? And now I can see, can I get groups of 32 out of those 80 tenths? So let's think about this for a second. Let's estimate. I'm going to round 32 to 30, so we'll say 80 divided by 30. We'll see if I counted by 30. It'll be 30, 60, 90. So 3 would be too much, but I think it'll be about 2 times, right? Right around 2 times. So we'll say that 32 should go into 80 at least 2 times. Now what I'm going to do is I'm going to put a decimal point here because now we're going into the tenths place, right? So since I'm dividing tenths, my answer has to be over the tenths place. So I'm going to put that 2 there, right? And 32 times 2 would actually give us, 2 times 2 is 4, and 2 times 3 is 6, so that would give us 64. So now I could subtract. That would leave me with 16. Okay, all right. Pretty good, but that's still a pretty big remainder. I wonder if I could keep going. I want to try to get that remainder down to nothing. I don't want there to be a remainder anymore. I want to see how exact of an answer I can get. Because I'm left now with 16 tenths. What would be the next place value down? If I was to decompose those 16 tenths, what would be the next place value down? Hundredths, right? I don't have any hundredths, but can I put another 0 here? Sure, now I have 0 hundredths. I'm going to bring down those 0 hundredths, and I'm basically regrouping those 16 tenths into 160 hundredths. Okay, so now I'm going to see how many groups of 32 I can make out of 160 hundredths. I'm going to divide 160 by 32. So if we think of this again as 160, and I'm going to round 32 to 30. Let's count by 30s. 30, 60, 90, 100. Nope, 30, 60, 90, 120, 150. So that's going to be too high. So I'm going to think it's going to be, or 190 I should say. I think it's going to be about 5 times. So we're going to say it's going to go in there 5 times at least, right? So I'm going to do 32 times 5, 32 times 5. So 5 times 2 is 10. 5 times 3 is 15, 16. Oh, look at that. Would you look at that? It's going to go in there exactly 5 times, which would give us 160 hundredths. Could subtract, and now I have no 0. So we took that remainder of 8, and we basically turned it into 25 hundredths. Okay? So now our complete answer, our more exact answer is 28 and 25 hundredths. Okay? Let's do the same thing over here and see if it works out to be the same. Okay? I'm going to let you guys drive a little more on this one. So again, I have that remainder of 8 ones, right? So I want to decompose that. I want to get it to the smaller amount, right? I don't want it to be 8 ones anymore. Now I'm going to think of it as 8 tenths. 8 tenths, but I don't have any tenths here. So what am I going to do? Exactly, I'm going to put a decimal, and then I'm going to add in a 0 in that tenth spot. So now I can, essentially bring down the 0, but really what I'm doing is I'm turning that 8 tenths, I'm turning that 8 ones into 80 tenths. So now I can try to divide those 80 tenths into groups of 16. So let's take a guess here. I'll round my 16 up to a 20, and I'll do 80 divided by 20. So 4. So it should go to about 4 times, right? 20, 40, 60, 80. Okay, so let's see. So I'm going to bring that decimal up because I am going into the tenths place now. I want to keep my place value straight. So 16 times 4. Well, let's do that real quick. 16 times 4. Let's make that look more like a 6. There we go. 4 times 6 is 24. 4 times 1 is 4, plus 2 more is 64. So that should work. So I'm going to put my 64 here. Subtract to see how many tenths I'm left with. All right, that would leave me with 16 tenths. So those 16 tenths that I'm left with, can I group them into a group of 16? I can. So that would actually stay in my tenths place, right? I didn't have to go to my hundredths, stay in my tenths place. So I'll be going in 5 times. Let me explain that. I estimated that it was 4, but I think we could have actually gotten closer. So let's try 5. Let's try 16 times 5 and see what we get. If I do 16 times 5, so 5 times 6 is 30. 5 times 1 is 5, plus 3 more would be 80. So I could have gone in 5 times. So what I'm going to do is, I'm going to take that 4 out of there, and instead put in a 5, which would have given me 80, and would have made this 0, okay? Cool. So 456 divided by 16 gives me 28 and 5 tenths. 904 divided by 32 gives me 28 and 25 hundredths. So you can see my answers are different now. My remainders, I've broken up that remainder and made it smaller. I decomposed it so I can get a more exact answer. So now we can see that they're not equal, okay? Because our remainders are going to be different once we decompose them, okay? So basically what we just did there under the guise of of comparing these problems was we actually did some decimal division. Okay, did you guys see that? We had the decimals that we added in to show that whether we're dividing whole numbers or whether we're dividing decimals, it's still going to look the same, right? We still have to find out how many groups we can make and move through the place value that way. We just have to make sure that we bring up that decimal point, and that we keep all of our place value organized so we don't get confused as to where we're putting numbers and what we're dividing and multiplying by, okay? Let's try one more example without doing the comparison thing. So this time I'm just going to start with a straight out decimal, okay? And I'm going to do 834 6/10, and I'm going to divide that by 26. So just like any other division problem where I'm using the standard algorithm, I want to think about each place value and just kind of move my way through. So first of all, if I have 800s, can I divide that 8 up into groups of 26? No, that's not going to work, right? What about 83? 83 tenths. I'm sorry, 83 tens. Can I divide those up into groups of 26? Sure, I certainly can. So let's do some estimation to see what that might turn out as. So I'm going to estimate this 26, I'm going to round it up to a 30. And 83, you know what, let's go ahead and round him up to 90 because that'll be nice and easy to divide by. So we're going to say that would be about 3, right? So 26, we should be able to make 20 groups of 26, at least 3 groups of 26 out of the number 83. So let's go ahead and do the 26 times 3. 3 times 6 is 18. 3 times 2 is 6, plus 1 more is 7. So 78. All right, that was good. 78. I'm going to go ahead and subtract now. So 78, 79, 80, 81, 82, 83. So that would give me 5. Then I could now bring down this 4 because now I have 54 ones left, right? I had those 5 tens and then 4 ones, so that's 54 ones. So how many groups of 26 can I make out of that? Well, I'm going to say right off the bat here, if I thought of this now as 25, because I can, even though that's not a round number, and then this I could think of as 50, because I know that 25 and 25 gives me 50, so this should be about 2 times. So out of the 54, I should be able to make at least 2 groups of 26. So let's see, I'm going to put this here. So we have 32, so 26 times 2. 2 times 6 is 12. 2 times 2 is 4, plus 1 more is 5, so 52. Pretty close. Pretty close. We'll go ahead and subtract that, and now we're left with 2. Now, if we were just doing whole numbers, that would be it, and that would be our remainder. Or we could keep going by adding the decimal and more zeros. But we actually have a decimal and a tenth right here, so we have to keep going. So I'm going to bring down this tenth. So now I have 26 tenths. Oh, and look at that. They're exact. So I know that 26 is going to go into 26 one time. We're able to make one group of 26 out of 26, and we subtract, and we're left with 0. So I want to go ahead and put that decimal point here. So my answer to 834 6/10 divided by 26 is 32 1/10. How could I check that answer? What could I do to make sure that that answer is correct? Exactly, I could do 32 1/10, and I can multiply that by 26. And if I did that, I would get 834 6/10. Okay, so hopefully that's making sense. We went through a couple examples real quick, but pretty much dividing decimals or by a whole number is the same as dividing whole numbers by themselves. We're going to follow the same steps, the same strategy to that standard algorithm. The main thing we just need to pay attention to is our decimal. Wherever the decimal is, we need to bring it up, so it's that in that same place in our quotient. Or if we happen to get in a situation where we need to add a decimal point and then add some more zeros to get rid of a remainder, we just need to make sure that we add the decimal in both spots so we don't forget about it. Okay? Hopefully this helps. Let me know if you have any questions, comments, or concerns. But this should be pretty straightforward. You guys are going to get some practice with this today. But if you hit any snags, please let me know. And as always, I thank you guys for watching, and we'll talk to you soon. Thanks.